Alright guys, this is your review for your Chapter 2 test on polynomials. Again, I'm only going to be able to work like one out of each section. On these easy ones I can do two. So let's get started because we got to get under 15 minutes. Where this is asking you for your real zeros, it wants to know where does it hit the x-axis. The second one is really simple because you can look, that's a -5 listed, so you can see it's -4, it's -3, it hits at the origin and then scoot over to 2. So you have 4 separate zeros. The first one is actually harder. It goes through -1, but y'all, it bounces at 3, which means you get 3 twice. So make sure you write it down twice because you have a cubic. Remember, this is an x cube. He's got the squiggle going on. So you got to make sure you have 3 roots down there. All right, your theorems. I'm not interested in you guys memorizing things. I need you to understand what they mean. The factor theorem, you need to tell me when you're dividing, you're looking for a 0. If you get a 0 at the end, then whatever you divided by is a factor. The remainder theorem, that's something you're going to use here in a minute. The short version on the remainder theorem is change the sign. So if you've got x minus 3, you want to use +3. Then you want to plug it in. That's the second part, plug in. And then the third part is you're looking for a 0. If it's equal to 0, then it was a factor. Whatever you started with was a factor. It's all about ending with a 0. So you can use the version I typed, you can make up an example and use it, as long as you can tell me what the remainder theorem is. Fundamental theorem of algebra, that's the easiest one. Whatever your degree is, so if you got x to the 4th, blah, 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 you're going to have 4 solutions. That includes your rationals, your reals, your irrationals, even the imaginaries, the complex. So that's all solutions put together. Okay, next part. This is where you have to use the remainder theorem. So this means take your little factor, set it equal to 0, change your sign. That's the number you're plugging in. So you're going to come down here and you're going to put -2 in for me. For every place the x happens, -2 goes in. Now make sure if you've got a power, you see over here, the exponent goes on the outside, because if you're typing that in your calculator and you put the exponent on the inside, you will get the wrong answer. You are more than welcome to type that in, but please show me that line. That way I know that you know what to do. But you can work this out if you just want to work it out. I do believe that comes out to be 34. Now there's a yes and no here, and what it's here for, it says determine if the given binomial is a factor. Well, what we just said was if it comes out as 0, it's a factor. So the question is, did you end with a 0? Well, no, we didn't. So come up here and circle no. Second one works just the same way. All right, next part says determine the quotient, which I'm assuming you guys know when you see quotient, it means divide. Of course, I kind of got it down here for you. I don't care which way you divide. You can do long division, you can do synthetic, whichever one works for you. I just need to know what the quotient is. If most of you are going to go with synthetic. Remember, if this is x minus 1, that means you're setting it equal to 0. You're getting a 1. 1 is what goes in the box. Then you've got to come through here and you've got to get all your little coefficients. Make sure you don't have any skips. Now, I'm telling you, one of the problems will have a skip. Like, if you'll pause just a second and look up number 2, if you'll see, there's no x's. So you would have to put in a 0 for this problem. I promise you, you will have one on your test that has a skip. You've got to know how to handle it. All right, let's go finish the one we started. Put your box under your last number. And remember, you start by dropping the first number. Then it's multiply, add, multiply, add. Do it again, multiply, add, multiply, add. So this is our quotient. It's not a factor because our remainder is -3. We didn't get a 0. If this is x to the 4th, take it down a notch. This is x to the 3rd. And whatever your signs are, that's the sign that you use to link your problem together with. So right here, since it's negative, I'm linking with a subtraction sign. You're going to put your x minus 1 right under there. Okay? Next part. The official name is the rational root theorem, but I put this so that you wouldn't be thrown off. All it is P over Q. Please stop once you get your list for P over Q. You do not have to divide them all out. Remember, P is the back number. It's your constant. So P in this version is 6. You got to tell me every number that goes into 6. And then your Q is your leading coefficient. And I should have done the other problem. Maybe we'll have time to do it. P over Q is basically your original list. But don't forget to put your plus minuses in. Once you do that, you're finished. Now, I'm going to give you one where you actually have a Q value. So here, P is just 5. You got 1 and 5. But Q is 2. I've got 1 and 2. So when you do your P over Q, everybody's got to match up with everybody else. Remember we said this is like a dance? Everybody's got to dance with everybody else. So do all your P values over 1. So I got 1 over 1, which is 1. 5 over 1 is 5. Now do everybody over 2. 1 over 2, 5 over 2. Remember, if you get a repeat of something you already have, you don't have to put the repeat. Just reduce everything. All right? Then you're going to get to the hard stuff. These are the ones where you do everything. So that's the reason I've got to find all your real zeros. And you know what? I shouldn't have said real. Because we're going to say this should be complex. Okay, your complex zeros, that's going to include imaginaries. So I need your list of P over Q's, and then I want to see your division where you found all of your roots, or your zeros. You're going to have one of each kind. One of these problems is going to work out nicely. One's going to have imaginaries, and one's going to have irrationals. Just for the sake of showing you something that's a little odd, let's do number 2 here. Number 2, let's see here, P over Q, just to make things quicker. Since you have a 12 and a 1 in front, that's just all the numbers that go into 12. Now, we know that we're needing to start with something in this list, but I told you guys that you could seek inspiration from your graphing calculator. At this point, this would be where it's wise to take your problem, put it in y equals in your calculator, and graph it. You want to see where your x-intercepts are. That tells you, gives you some insight as to what to use here as a divisor. If you will put down all of your coefficients, then you can come through and divide it out. I'm trying to remember what worked on this problem. Well, let's just try 1. That's going to give me 1, 4, 4. That's not going to work. Let's try 2. That would be 2, 5, 10. That's not going to work either. I can't remember what works on this problem. I bet we need a negative. That would be a negative 2 and a 1 and a negative 2 and a 2. Oops. Need my eraser. What about a negative 3? That'd be negative 3. There's a 0. And that's going to be 0, 4. Here we go. Finally found a winner. So this is x squared plus 4 equals 0. It's your job to actually solve this. So you got to move your 4 over, make it negative. You can come in and square root. Remember, it has to be a positive or a minus, positive or negative. When you do the square root of 4, it's 2, but the negative gives you the imaginaries. If you would be so kind as to come over here and list all your roots for me, I would appreciate it. You got a negative 3, and I don't care if you put these together, just as long as you understand there's 2 of them there. So you have a total of 3. 1, 2, 3, and your degree was 3. So it does follow your fundamental theorem of algebra. When you do this one, we'll see if we can get this one in here. It says short list for P over Q, but whenever you start dividing, you got to get all your coefficients in here. This one's longer because it starts as x to the 4th. Guys, you're going to have to do synthetic division twice. So drop your 1. You're going to multiply and add. What is that going to be? 9. And that's going to be 18, negative 2, and here we go, negative 4. Yay. Remember, that's when you dance. That's when you get a 0. All right, you got to do it again because we've got too many terms here. We don't need 4, we need 3. So try negative 2. And yes, I've seen what the graph looks like, so I kind of know how this one works. But seek some inspiration from looking at your calculator. That would be negative 2. Here we're going to have, what, 5? Negative 10, negative 1, 2, perfect. Now, the problem is, you get a quadratic, that's true, but you can't factor that thing. So you have to go to the quadratic formula. Guys, when you do the quadratic formula, I'm not giving it to you. You have to know x is equal negative b plus or minus the square root b squared minus 4ac all over 2a. It's your job to know that. So A is 1, B is 5, and C is negative 1. You'll put them in there, do the opposite of B, square the B. A is 1 and C is negative 1. If you leave off the negative, this problem is just going to blow up in your face. When you work this out, you have 2 negatives there now. 2 negatives make a positive. So that's plus 4 all over 2. So negative 5, plus or minus, square root of 29 over 2. You can't go any further because 29 doesn't break down. So if, again, somewhere on your paper, if you'll give me a list, 2, negative 2, and then we've got negative 5 plus or minus square root of 29 over 2. That's a total of 4 zeros. I need to see them. Now the last thing on the test is where you've got to go through and get your zeros. Remember, you got to write them as factors, which means change signs. And then you're going to multiply them together. Multiply 2 of them, get that answer, and multiply it times a third one. I'm not doing this one because this is the nice one. Let's do one that's kind of gross. When you see this, I'm telling you it's third degree, but you only see 2 things. You're supposed to know you have a negative square root of 5. So then it's x minus 3, x minus square root of 5, and x plus square root of 5. All right? Now, the wise thing to do would be to multiply these 2 together first. So make this first factor just weight. You got x squared plus square root of 5x minus square root of 5x minus 5. Okay, make sure you got that last part. Square root of 5 times square root of 5 is just a regular old 5. The radicals go off. It should work where these 2 middle terms cancel every time. If it doesn't, then you need to go back and find your boo-boo. Then all you have to do is multiply these out. You got x cubed, and that's going to be minus 5x minus 3x squared plus 15. And be nice about it, clean it up, and put it in descending order. So just swap those middle 2 so everything looks good. The last one has got the I, but guys, if you've got an I, you should know the other one comes with it. They're married. This one is a 4th degree, so it's going to be a little bit more involved. All right, always do the I's together first. If you have 2 out here, you can go ahead and put them together. I'm just going to try to expedite this, so I'm going to do part of this in my head. Sorry, but I think I'm approaching the 15-minute mark. When you multiply your complex factors, that's x squared minus 2ix plus 2ix. And here we go, minus 4i squared. You guys are supposed to remember what this does. The I squared changes that sign. So we're going to kill that off and we're going to put a plus 4. That's what we need. So you got this crazy trinomial out here, and then in here your i's should disappear. So it gets really small. And then you can just factor that one out and finish. Excuse me, not factor, distribute. Y'all should be good. Good luck on your test.